welcome. For the next 20 minutes also, I'll just briefly give an overview of this year's challenges. We have to end in 18 minutes exact, so I'll try to talk about this as quickly as possible. As David mentioned in the beginning, this is the 20th year of CAMDA challenge, and unfortunately, because of the pandemic, it is taken place in a virtual space instead of meeting in person in Lyon this year. So first, allow me to pay a little tribute to the pioneers who took on challenges of massive data analysis back almost 100 years ago. And as we all know, of course, one of these pioneers is Alan Turing, who took on the challenge of Enigma back in the 30s and 40s of last century. As we know, he utilized both algorithms as well as hardware development to solve the challenge and crack the code. And this success was built on previous success by the Polish scientists, for example, Marian Rejewski and his colleagues, who took on the same challenge and invented the Bomba machine, which cracked the code of Enigma. And we know the tremendous impact of this success in solving this computational challenge on the society and the savings of human lives almost 80 years ago. Perhaps a little bit unknown to the audience would be the success of Turing back almost 70, 80 years ago in studying some of the mysteries in life science. For example, this beautiful pattern as seen in Nature. So this was a publication in 1952 where he tried to explain the chemical basis of morphogenesis using the so-called reaction diffusion model, as you can see here. And this particular development is still impacting, in this particular case, primary school children today to learn the wonders of biology and mathematics. In this particular example in the UK. As some of us might know, back in 1949, Turing said about computer science and the future of artificial intelligence that this is only a foretaste of what is to come and only the shadow of what is going to be. It may take years before we settle down to the new possibilities, but I do not see why it shouldn't be enter any one of the fields normally covered by human intellect and eventually compete on equal terms. This is obviously true for computer science and artificial intelligence today, and I surely hope that this is applicable to CAMDA challenges and the CAMDA conference as well. So in this spirit, we invite everybody to join us this Friday at the CAMDA Cafe to discuss this year's challenges as well as future challenges of CAMDA. So back to this year's challenges, we have 4 challenges. The first one is Cancer Prognosis Data Integration Challenge. As we heard from the excellent keynote just a minute ago, there's an amazing comprehensive collection of omics data in cancer. The most prominent data sets are provided by, for example, TCGA, as we heard from Francisca's talk, with additional data from the organizers. So I listed the names of the organizers for each challenge, and please contact them if you're interested in any one of these challenges. In particular, this year, the organizers provided additional Pan-African contigs that are not mapped in the reference genome. And when they were mapped to the TCGA samples, they accounted for up to 5% of the reads in some of those samples. So one of the goals of this challenge is to develop and demonstrate novel methods for gaining novel biological insights on the cancers, for example, using these previously unknown Pan-African contigs and other knowledges on cancer to improve support for precision medicine. So this is our first challenge. Already heard the excellent keynote delivered by Francisca. And this Friday, there are a couple of additional talks about the results of this challenge as well. Our second challenge is a continuation by the MetaSub International Consortium. And in particular, this year, the focus is on phage-based resistome. As we know, phages are the most abundant viruses on the planet, and they're specialized in infecting bacteria. The systematic characterization of phages were not possible until the age of metagenomics. So it is really exciting time to explore these previously ignored, little DNA pieces in the world. And as we know, phage therapy has been rediscovered in both academia as well as in pharmaceutical companies as a potential alternative to antibiotics in medicine. So a better understanding of the interaction between phages and the bacterial host would be of great value to public health. This year, 62 samples with high level of antibacterial resistance genes and 62 samples with low level of antimicrobial resistance genes were provided. And this was an initial large-scale analysis of the antimicrobial resistance project of the MetaSub International Consortium. So we're going to have a keynote tomorrow on the microbiome data science, and I encourage everyone, if possible, to join us for that keynote, and also a presentation on the discovery between the relationship of bacteriophages and antimicrobial resistance, again, tomorrow before the keynote. Our third challenge this year is a continuation of our collaboration with the FDA National Center for Toxicology Research. And that is about the literature AI for drug-induced liver injury. As we know, drug-induced liver injury is of significant concern by regulatory agencies, the FDA, the European regulatory agency, as well as other regulatory agencies around the world. And currently, this knowledge is collected from the free text of scientific publications, which is currently analyzed manually. So there is a significant opportunity for using literature AI to gain the knowledge on drug-induced liver injury. So this year, the organizers have compiled a large set of PubMed papers relevant to drug-induced liver injury as positive set, as well as a challenge set of unrelated papers as negative set. And in addition, there's a third independent validation set to evaluate the performance of the algorithms submitted by the participants. So after this section, there's going to be a section on the results from this challenge. Again, we invite everybody who can attend. Please attend this section. And tomorrow there's also another section on the results from the same challenge. And we have a invited talk from FDA on the application of artificial intelligence in regulatory science. And the last challenge is a new challenge, which is from disease maps to modeling of COVID-19. As we know, this is the challenge that has a significant society influence in the world of crisis right now. And the organizers teamed up with this disease maps initiative, which has developed and compiled a large collection of COVID-19 mechanistic maps, which captures our current understanding on the disease. So the idea is to explore these maps for the identification of the mechanisms and functions in the disease in search for candidate targets or intervention points that might be able to help us to cope with the disease. And we challenge the participants to utilize this great resource and try to solve one of these challenges of great importance for the society right now. And this is obviously of significant social impact, as we know. For example, this is one of the news from last week on the Delta variant, which apparently has a viral load of roughly 1,000 times higher than the viral load before. So hopefully the results from this particular challenge can help the society, just like what Turing and his colleagues did almost 80 years ago. So with respect to this particular challenge, today, later than this particular section, we have a section that discusses a couple of results with respect to this challenge. And Friday, there's an invited talk on the mechanistic models for COVID-19, followed by a couple of additional talks on the results of building mechanistic models against COVID-19. So with that, I just want to conclude. Please vote for the best presentations as we did for many years and enjoy the conference. I just found out that this is apparently a new circulation of 50 pounds in the UK, started last month to honor Turing, and hopefully we can get results on our best presentations, and David might want to comment on what rewards